Hello. In this video, I am going to introduce the topic writing linear models or formulas. We have two goals with the lesson today, and that is to write a linear equation in the y equals mx plus b format, and that would be for a word problem or real-life application. So the information may be presented in words, it may be presented as a graph, or it may be presented as data. And then the second goal is to answer questions using that model. So answering questions for either data points that are not given or for predictions about what might happen next. So let's review our pre-lecture work on linear models. We learned 2 weeks ago that the equation for a linear model is y equals mx plus b. And we know that in that equation, the m is the slope or the rate of change, and the b is the y-intercept, meaning it falls on the y-axis, or it is the starting point or initial value. We also learned the formula for slope, and this is a formula that you want to know for your final exam. So I did not write the formula on that last mini test. You need to learn that formula. So the formula for slope, we would say m equals rise over run, which is a concept that's great for graphing. It's the change in y divided by the change in x, which you can use when you have a table of values. Or there is a formal formula. In the formula, we subtract the y values, always using the y2 or second y value and subtracting y1. In the denominator, we subtract the x values, again, always using the y2 or second x value first and subtracting. So in order to write any linear problem, we need two things. We need a starting point, that initial value, which is b, and we need the slope or rate of change, which is m. So if we can calculate these two things, or if we're given one and have to calculate the other, we have to figure those two out, and then we can write our formula. So let's take a look at an example. In this example, we have an insurance salesperson, and they are getting paid a base salary plus some commission. And so what we see is that we see that 3 policies goes with an earning of $760 for the week. So these two numbers go together. They are somehow joined. And then later on we see that when we have 5 new policies, so I'll put that in red here, 5 new policies goes with $920. And so those two numbers are also joined. So when we're working with any formula, we need to figure out which variable should be our x and which variable should be our y. We've already talked about that the ordered pairs always come in alphabetical order, x and then y. We also talked about that x is independent and that y is then dependent. We also added words like x is the input variable and y is the output variable. So how does that make sense in the context of a real-world problem? Well, the x variable is the thing that must come first. So in this scenario, the salesperson must sell a policy before he gets an income from it. So selling policies has to come first, and so you can see in both of my ordered pairs, in both of these groupings, I made the number of policies x and the money y, because you can't get paid until you sell the policy. That allows me to correctly set up my slope equation. So we know that m is equal to y2 minus y1 over x2 minus x1. So you see that I took the second y value, so I'll call that y2, put it in first. First y value went in second. Same thing with the x values, preserving that order, and I got a slope of 80. And that slope, because the top here was money and the bottom was policies, this slope is $80 per policy. Now, that's great because the m is one of my letters. So I go to my y equals mx plus b, and I know m, so the m is 80, and you can see I plugged that in directly down here. But what I don't know is b. They did not tell me the starting salary. They did not tell me the base salary. They told me there is a base salary plus commission, but they didn't say what it was. So I know that the ordered pairs I have, both of these ordered pairs, actually work in the formula. And so I can fill them in for x and y. So you see I put in the first ordered pair, I put in the x value of 760, and I put in the y value of 760, and I put in the x value of 3. And then I did the math. So 80 times 3 is 240. I subtracted 240 from both sides because in algebra I always do the opposite. And that's how I got an answer that b is 520. So in my final answer, I have filled in the value for m. I have also filled in the value for b. So the base salary is 520, and then this salesperson gets an additional $80 per each policy that they sell. Let's take a look at another example. So in this example, we have a population of a town, and we're told it's growing linearly, so we know that we can use y equals mx plus b. In this scenario, the input is going to be the year, and that is because you have to know what year it is before you can look up the population. So the year, you have to know this first, and that makes it the x variable. And then the output, which I have as P of t because it's a population, but the output, this can also be the y value, it just depends on what you like, is what we would look up. So once we know what year we're going to work with, we could look up the population. So in this scenario, the author converted the first year as year 0, and we did that because we would say this is the start of the trend. So we were told that it's a linear trend from 2004 to 2009, and we would start the trend at 2004. So the way that we made the numbers in the problem, so in the problem, my original number was 2004, looked that up, and said that was a population of 6,200. My second year was 2009, looked that up and said population 8,100. And so putting the year in for X, putting the population for Y, and then we made the first year, year 0. So instead of using 2004, using 0. That means 2009, which is 5 years later, is going to be year 5 of the trend. So you see down here, this is my X as year 0, and this is my X in this one as year 5. So then I use these ordered pairs to figure out my slope, and we know that's subtracting the y values, subtracting the x values, and we figure out that we have a population change of 380 people per year. So this is my m. And so in my y equals mx plus b, you see that I put that in for the m. Now, because we used the convention that 2004 was year 0, that made this 6,200 the starting population. And so I don't have to do extra algebra to figure out B. I actually know that B is 6,200. And so that's what we tried to put in words right here. Because of making 2004 year 0, the starting population is known. So we have Yet another example from our video, which reviewed for us that slope is the rate of change, that it's found by taking the change in y over the change in x. We have talked about previously that x always comes first. So in our data, x is the number of toppings, y is the cost of the pizza. To find my slope then, I actually looked at, and you can see all my chicken scratch here, of how were the number of toppings changing. So it went up by 2, up by 1, up by 3. And then I looked at how was the cost of the pizzas changing. And then I just took this first group of numbers. So right here I have a change in x value. X went up by 2. And a matching change in y value. Cost of pizza went up by $3. And I put the y on top, x on bottom, and got my slope that way. The meaning of this slope can be figured out by looking at what the meaning of x and y is. So on the top, we have money. And on the bottom, we have toppings. And so we can figure out that the slope is the cost of $1.50 per topping. And keyword in figuring out that slope or rate of change is always the word per. When we look at a graph, we often use the concept of slope as the idea of rise over run. And so when I look at this graph, the rise, the vertical change, which is from the y-axis, that vertical axis, is actually a drop of 1 from one point to the next. And so I see that rise, that change in y, is -1. My run, which comes from my x-axis down here, and to get from one point to the next, I go over 25. Now, we've talked about before that you can use any 2 points, and so truly I can use any 2 points. So I don't have to pick points that are exactly next to each other. And you see that in the second triangle that I drew out. So here, to get between the 2 points, I have a vertical change of going down 2 and a horizontal change of going over 50. And then when I reduce that fraction, it is the same value for the rate of change. With the negative, this fraction is a loss of 1 gallon because our gallons went down by 1 when we drive for 25 miles. So I hope that this introduction made sense and refreshed these concepts for you. In our next videos, we are going to look at examples and figuring out the values and the linear equation for those examples.